So far, we've been focused on hard tissue anatomy, the skeletal differences between humans and great apes. The fossil record preserves hard tissue anatomy. It preserves skeletal anatomy, so that's where we'll focus most of our efforts. However, it is necessary to point out some of the important soft tissue differences that exist between humans and great apes. The origin of these differences is something that we'll certainly be considering within the fossil record, even if the fossil record is only indirectly providing evidence to address these changes. First and foremost are some visual differences between humans and great apes. Although we're very similar in terms of our skeletal morphology to the great apes, we look quite different. One of those differences is we have a lot less hair. We're not necessarily covered in hair from our heads to our toes. Some of us might exemplify this difference a little bit more significantly than other humans, but in general, humans are relatively hairless compared to the great apes. Other major differences include the relative fatness of our bodies. Especially human infants tend to be very fat relative to those of the other great apes. It turns out subcutaneous fat is an important soft tissue difference between humans and the great apes. While we have essentially the same muscles as our great ape relatives, the position and relative size of those muscles differs significantly. We'll see this again when we move ahead and look at the origins of bipedality and how the musculature associated with bipedality and the structures, the physical skeletal structures associated with bipedality differ between humans and the great apes. Humans and great apes also differ in the form and structure of their external genitalia. Many primates, including great apes, have large swellings that appear around their genitalia in females associated with periods of estrus, or when females become reproductively fertile, as these structures serve to be visual markers of the reproductive stage of females. Humans lack this kind of visible estrus, which is an important difference in the reproductive morphology associated with humans and great apes. In males, across the great apes, we see large differences in the relative size of the testes, associated with different reproductive behaviors. Chimpanzees, for example, have relatively large testes, associated with sperm competition that goes on with reproduction, whereas gorillas have relatively small testes. Humans sit in the middle with this regard. These differences in reproductive morphology are important even if we can't directly address them in the fossil record. They represent important ecological differences in terms of how humans and the great apes reproduce that are important to factor into the evolutionary models we try and create out of the fossil record.